Hi guys, welcome back to my channel. Myself Bharat Ji. Today I am here with a small topic, comprehensive numerical prototyping of paper-based micro devices using open source tools. Now let us move into. For the beginning, abstract. Paper-based microfluids has emerged as a promising fields with devised applications ranging from medical diagnostics to environmental monitoring. Despite significant progress in search and development, the translocation of paper-based prototypes into practical end-user devices remains limited. This limitation stems from challenges related to devices not being sufficiently portable and autonomous, which paper-based microfluids is expected to overcome. Yet for this purpose, we note that the lack of comprehensive numerical modeling tools capable of stimulating the interact psychochemical phenomenon involved in order of optimizing the development process. Hence, in the study, we introduced Force Microtransport, a novel stimulation package integrated with the open source platform OpenFOMA, designed to address these challenges. Force Microtransport offers efficient solutions for the fluid flow and the transport of phenomenon in a microfluid process media, including capabilities, models, and biochemical reactions. Moreover, under horizontal flow condition purpose microtransport applications fields can be extended to any pores of media. We demonstrate that the software effectiveness in two example cases showcasing its ability to accurately reproduce complex phenomena involved in paper-based devices by virtue of being a easy and computationally efficient tool. Force microtransport facilitates the design and optimization of devices, potentially enabling more devices to meet the point-to-point testing. We can accept that this tool will accelerate the development of robots and prototype diagnostics of devices, bridging the gap between the particular applications. Next, introduction. Paper-based microfluids is nowadays a well-established R&D field. However, the number of end-user applications is still certainly limited. The success of lateral flow assays, initially developed for pregnancy test and more recently widely spread with the rapid test for SARS-CoV-2 detection, could not be replicated by any of other microfluid paper-based analytical devices. Despite the huge effort made by the scientific community to develop to compile with the research certain purpose by the World Health Organization. At present, only a few examples are available for end users as a real point of need testing devices. Many approaches have failed to corresponding authors simultaneously fulfill all the research certain mainly due to a high level of dependency on extra requirement for specifying and complementary tasks such as heating, driving fluids, accurating values, incubation, and reactions among the others, including these tasks within the functionalities of pads required, increasing the complexity of devices with the consequent on designing and fabricating processes. Nevertheless, the participation of optimistic consequence of design and fabrication process. The currently working on improving as many researchers both in academic and comprehensive and currently working on improving different aspects of pads in medical diagnostics, environmental monitoring and food quality control among other fields to perform more complex tasks while being more reuse portable and efficient. Next, materials and methods. Ports Micros Transport has been developed as an ad of one open FOMO, an open source multi-physical platform for solving practical different problems. Ports Microphone Transport can either be compiled from its source code or downloaded in a pre-compiled form as an docs image. For completion from source, Ports Micros Transport only requires as a development installation of OpenFOMA V2112 or later as an distributed by the Open CFD Limited. As OpenFOMA Ports Micro transports its open source software available under the GNU General Public License V3.0. Notable, the software includes an automated test suite that can verify the correct order of run separate test case in parallel, taking maximum advantage of the available computing resources in order to achieve every reasonable existing time as less than a minute for entering the code responsible in order to ensure that any processed change do not negatively impact existing functionalities. This continuous integration test is also a test for compatibility with all supported open format versions and uploads new doc, Docker images of necessary. For its part, the user-facing definition of ports micro transports cases is deliberately inspired by Port's multi-phase from another toolbox for open format dedicated to multiple flow of transport in the soil. Next, results and discussion. Three tutorial cases including in Port's microtransport are presented, discussed and compared with the experimental results with the aim of demonstrating its capabilities. For the numerical prototyping of complex devices, the selected examples include multiple intels for unsaturated flow, sequential delivery, class automation using exhaustible reservoirs. Multiple slots are as reactants and products including pre-absorbed species and also two different reactant mechanisms. The results obtained are compared with the experimental results present in literature to show Pore's microtransport accuracy, while its rebootness is shown through the complexity of the device and its operation. In both devices manufactured by the authors to make the comparison of mixing performances. Such performances is evaluated through the color profiles demonstrated at the gap cross section. In table 4, the transport and reaction properties of reactants are reported as well as the concentration of every reactant at its particular Intel reservoir. All of the stimulation data of reproducing this tutorial case can be at the reservoir. The reported concentration is imposed as a Dirichlet boundary condition as well as the full saturation condition for the ambitious flow solver. For the other boundaries of the demonstration, the condition for transport and flow is a natural pneumo condition, either on fluid or not solute flow in the normal direction to the boundary. At the end, conclusion. In this work, we have introduced a novel open source tool for the comprehensive numerical prototyping of developers as a very competitive numerical tool for designing and optimizing to be used before and coupled to experiments in the classical iterative path from the concept to product. We expect that in the near future, with the aid of ports named ports microtransport, the software is distributed as an extension for the well-known operation from a finite volume-based multi-physical platform, inheriting all of its advantages such as arbitrary 3D mesh compatibility, parallel and supercomputing support, compatibility with high-performance data visualization, and one of the most active developer communities for open source simulation software. It is important to stress that Ports microtransport as it's integrated to open form or can be easily modified or extended in order to model another important administration Pablo A. Kailer conceptualization, validation, writing original draft, project administration, FEMA such as an heat transfer, pressure driven flow as an electrochemical detection as well as more general length scales for the studied domains. It will also be possible in the near future to integrate ports microtransport with the related packages aimed to electromostic and electro protective flow and transport. Thank you for watching my video. Please like, share and subscribe.